Today I'm going to talk about building amazing GUIs with Roact and Rodux, our new UI and state management libraries. My username is LPG Hack Guy on the platform. I was a user 10 years ago, so I joined in June of 2008. For reference, back then, I was 10 years old when I joined the platform.
I remember you.
Thanks. So I joined as a 10-year-old, right, and made a whole bunch of games. One of the games I made was one of the first RPGs in Roblox to have dual-wielding swords. You haven't heard of it. It didn't go anywhere. It was basically just a tech demo. But now I'm here working at Roblox. I got a job back in February 2017, and I was hired for my Lua expertise. Naturally, I was on the platform for 10 years. It gave me a lot of insight into what the problems that developers face. Oh yeah, one more thing. I'm on a team called Lua Core. So the team is dedicated to improving the quality of Lua across the company and making sure we have the libraries and tooling we need. It also expands the developers. Anything we can do that we can release, we will release. So here's what we'll talk about. I'll talk about the origin of all these projects through the guise of the Lua mobile chat project. We'll talk about 3 key challenges we identified before we started on that project. And finally, we'll talk about some solutions that we developed to fix the issues. And then we'll have a lot of time for Q&A. Let's jump right into Lua mobile chat. From a product perspective, Lua mobile chat was a really simple goal. We wanted to rebuild our chat on iOS and Android using the game engine. Sounds crazy. It's a game engine for building mobile apps, but we figured it's a great way to flex the muscles of our UI system and fix any holes that we have in them. It's also a great way to prove that our platform is robust and can be taken seriously. We already did this with Xbox and the avatar editor on mobile, so we had a fairly high confidence that it would work pretty well. Here's a screenshot of our mobile chat on Android. Can you tell if this is native or Lua? It's native. I didn't have a screenshot in time for this presentation. But the idea is that it should be an exact carbon copy, and you should not be able to tell. From an engineering perspective, we had a couple different goals. First of all, there wasn't any automation testing for Lua code at Roblox before I was hired. This freaked me out. I wanted to use this project as an opportunity to implement automated unit testing and integration testing and end-to-end testing as much as we could. Second, I wanted to improve the quality of Lua code across the company. Generally, our core scripts are fairly hastily put together. Many of them predate module scripts even, which is not great. So trying to bring in practices from outside Roblox, especially to try to improve the quality, is important to me. And finally, I wanted to make sure that anything we build that we can release, we will release. We built up several libraries. We have some we're introducing today, and then more we'll be introducing over the next couple weeks. So we identified some key challenges. The first of which is automated testing. Thankfully, automated testing is actually pretty straightforward. It's just tedious. You have to write tests if you want your product to be robust, but you work through it. Again, there was no automated testing for code at Roblox. It looks like my emoji was changed on this, or is in a different font in this presentation. Imagine this with the Google emoji set with the very visceral scream. That's how I felt. Roblox has test service already. It's marketed as a way to write tests, but it's really designed for engine code. It's not exactly ergonomic. There's no way to structure your tests. We don't really provide any tools for running test service tests very easily. Outside Roblox, there's a lot of libraries that people use that are really great. There's Busted for Lua, for example, if you've worked outside Roblox. There's Mocha and Chai for JavaScript, and then Ginkgo and Cargo Test for some more structured languages. The second problem that we identified, the challenge that we needed to solve, was how to manage our state effectively. Lots of code in apps and games alike need to read and write data. Your networking, so your remote events, your HTTP requests, your data store calls, and anything that your user does needs to modify and interact with your application's state. Everything needs to agree on what that data actually is, or else you have desyncing. You'll have very angry users. Bug reports where a user thinks that they have a certain amount of currency and they have a different amount of currency are not very fun. Bug reports where users think that their items are disappearing or their items are being swapped around in ways that they don't expect are not fun. So we talk about this idea of state ownership. State ownership defines who gets to write to data and who gets to read to data, and how the data flow works in your application. If you're careful about state ownership and have a single owner of data, it's very easy to keep data in sync. Outside Roblox, there are some dedicated state management solutions. In JavaScript, there's Redux and MobX that are primarily used with frameworks like React. There's also dedicated UI frameworks that have two-way binding models like Angular and WPF. The final problem that we wanted to address was dynamic UI. It's really, really hard to keep data in sync with your UI. Like I said, it's a really bad bug when it happens. So if your currency is out of sync, your inventory is messed up. It's also very, very difficult to sync different kinds of data. But again, Well, currency is pretty simple, right? A value changes, you set a text label text. It's pretty hard to mess up. Some other pieces of data, though, like lists and grids of items. Again, I mentioned inventories are usually grids. It's very, very hard to keep those in sync with each other. So imagine we have a list. It has 3 elements in it, foo, bar, and baz. And then we get some curveball from the server, and now we got to render oof and foo. You could look at this and say, oh, well, foo moved to the 2nd position, and we inserted a new item oof in the 1st position. Or maybe bar was renamed to oof. Or maybe foo was renamed to oof, and we added a new foo. There's a whole lot of ways that this state could be encoded that we have to identify. So as kind of a divergent, we'll talk about the major UI paradigms and how they can be used to address this problem. First up is retain mode UI. In a retain mode UI system, all of your UI is represented by persistent objects. This lines up with how we have it in Roblox. You create a frame object. You create a text label object. You change properties on those objects to enact change in your UI. It's fairly straightforward, right? Everything's persistent. There's no code running all the time to keep a static UI on screen. So imagine you have a text label that says, hello there. And we want to change it to say something like General Kenobi, right? All we have to do is set the text of that label. Simple imperative code. Let's go back to that list example, though. What is the retain mode way to modify our list, our previous foo, bar, baz list, and change it to our oof and foo list? It's complicated. This is an endless rabbit hole of algorithmic complexity and difficulty that you can't really fit on a slide very succinctly. Again, we could rename elements. We could reuse them. We could just throw everything away and recreate it every frame. We tried that. It's very slow. The other approach that you can use for UI is immediate mode UI. In an immediate mode UI system, like your ImGUI, you basically rebuild your UI every frame, but there's no persistent objects to change. You call code every frame that describes what your UI should look like at that instant. You don't have to worry about updating your UI. Your UI will simply represent exactly what the piece of data is that's backing it. It's the gold standard for ergonomics. It's very, very hard for data synchronization bugs to be introduced in an immediate mode UI system. It's often used for debug UI, where it's very critical that your UI is accurate, or else you might be working off wrong information. It does have significant performance problems if we're not careful. Laying out text is a notoriously complicated process, and our UI system at Roblox has to take very, very careful steps to make sure we don't recalculate text too often or recalculate UI list layouts too often. So we'll talk about the text label example. In an immediate mode UI system, we can just say the text is hello there. When we transform to our great exclamation, all we have to do is change what we call every frame. It does mean that our code runs every single frame. Again, downsides in performance. But when we look at a more complicated example, like our list, to represent our first list in an immediate mode UI system, we might just call a function that says foo, bar, and baz. It just works. Then, to change to our new list, all we have to do is call the function with different arguments. It's great. But again, performance problems, but massive ergonomic gains using immediate mode UI. Outside Roblox, we're talking about two different techniques that people use for UI. One popular approach is Scaleform. It's used by a lot of AAA games. It's Flash-based. It's made by Autodesk. Naturally, we're not going to bring in a Flash-based UI framework into Roblox. That would be insane. It's 2018. But it was used in Grand Theft Auto 5. It was used in Skyrim. It was used in lots of games that have generally pretty good UI. Skyrim's UI on PC is not excellent, but Grand Theft Auto 5's is awesome. Their map is also rendered in Scaleform. Another approach we could use, taking a cue from web development, would be React. Now, a lot of game developers, especially core client engineers, when they hear bringing a web technology in, they groan. They're like, oh, no, not JavaScript stuff. We don't want that anywhere near our nice engine. So it's made by Facebook, right? It's used by Airbnb, Uber, tons and tons of really big companies. They use it for mobile apps and for websites as well. It was used in Battlefield 1, though, so the game industry is starting to take notice. There was basically just a brief exchange in a comment in the React issues where an engineer from DICE mentioned, hey, we wrote a custom renderer for React, and we used TypeScript and React for writing all of our UI in Battlefield 1. It meant that they could dynamically update their UI, and they didn't have to deal with a bunch of bugs. So we'll recap over the problems we just talked about and then the solutions we came up with. For automated testing, we built a library called TestEZ. For state management, we built one called Rodux, cleverly based on the name Redux. And for dynamic UI, we made Roact, of course, picking React over Scaleform to take cues from. Let's talk about TestEZ. TestEZ is what's called a behavior-driven development testing framework, BDD. That means we describe tests in phrases that look fairly like English sentences. Your tests read very, very fluently. Some people might also pair it with a fluent interface, you could say. It runs inside Roblox. We use it for both testing normal scripts and core scripts. You could run it in local scripts. You can run it in whatever script environment you want. We also use it in an emulated environment called Lemur that we use for running on Travis CI for continuous integration. Talk about that a little bit later. TestEZ test looks like this. This is a fictional datetime library that was kind of modified off of an existing real test we have in our code base. We describe the datetime library. It's hierarchical. We can describe the new method, and that it should construct a datetime object. We say, OK, well, we should expect datetime.new to be OK, non-nil. And then we also describe our format function and have a specific case of a date that we need to format. So for example, we want to make sure that the party date, 1999, December 31st, is correctly formatted. We'd naturally have a bunch of other test cases. We can run it on the command line like this, just through normal Lua. This is with Lemur, emulating Roblox. We can also run it, again, we run it in our automated testing systems internally. And we also can run it in a normal game. At any time when we're working on our apps, we can actually run the tests in real time on device. Let's talk about state management. Rodux. So it's based on Redux, if you couldn't guess, made by a guy named Dan Abramov. He's now an engineer at Facebook. When he created Redux, he was not. He got hired because of it, partly. It's based on 3 very, very simple principles. First of all, there's a single source of truth for all state. It goes back to the state ownership idea we talked about. State is read-only. That means that it's OK to take a reference into your state. You're not going to have to deep copy things or worry about them changing out from under you. If you get an object, it will always be exactly the object it was when you got it. Then we also define state by what are known as pure functions. We call them reducers. Reducers just take the current state and an action and then return the next state. They don't mutate the actual state. They just return a new state that represents the change that could have been applied. Cool thing about Rodux, you can implement it in only 20 lines of Lua. It's more about the patterns and techniques behind it than the actual implementation. So I did that. I made a version in 18 lines. And it's almost entirely feature complete. The one feature missing here is you can't unsubscribe from the store here. But you could use this today. You can also use our real version, which has type checks and other additions to it that bloat the line count naturally. I think it's about 70 lines of code as opposed to 18. So let's talk about a quick example of how to use Rodux. First of all, you create those reducers I was talking about. It's just a function. Everything is very anti-magic. We accept our state and an action. We use Lua's default value tricks that we normally have, like we say state is state or 0. If state's not defined, it'll be 0. And then we check the action. Conventionally, we define it as a type field. We just compare it with a string increment. If we wanted to increment the state, we just return the old state plus 1. We can't change numbers in Lua, but we don't change it anyways. And then if nothing else hits, then we return the current state. Then we create what's called a store. A store accepts a reducer. The store will use the reducer to process the state and cycle through your state machine and cycle through any other application state you have. Next, then we subscribe to state changes. So in this case, again, we're using a retain mode UI framework. So we'll just listen to the store changes, and we'll say, anytime it changes, we need to update this piece of text. It's very, very simple. And then finally, we can dispatch actions, is what we call them, to actually change the store. So here we are just making a plain old object that has the type increments, and we send it to the store. It goes through our reducer. We'll get a new state. It'll update our text button. Everything's great. Next thing, dynamic UI, Roact. That's based on React, again, by Facebook. In Roact, you create components to represent the reusable pieces of your UI. Not everything has to be reusable, but it's a pretty convenient model to think about modeling your UI. Components receive state and what we call props, and they return a description of what they wish the UI looked like. Does that sound familiar? It's like immediate mode UI. It uses retain mode UI under the hood, and Roact actually will update your Roblox UI objects for you as efficiently as it can. There's a great white paper published by Facebook Engineering on this that talks about the algorithmic complexities involved and the trade-offs that you can make and heuristics you can develop for this. But in the end, Roact tries to pretend that it's an immediate mode framework. It's declarative without giving up any of the benefits of retained mode. It pretends to be an immediate mode framework without giving out any of the benefits of retained mode UI. But you don't have to deal with any of the bugs that come with retained mode UI. So here's a simple example in Roact. We define an alias, mostly so that the code will fit on a single slide. Then we can just describe our UI. So here hello is just a screen GUI, and it contains a text label that has some text in it. No, I've omitted the sizing and other things you need to do to set up a new text label to fit on the slide, of course. And then finally, we just tell Roact, hey, here's my description of my UI. Can you make it real? We call this process mounting. I mean, this UI is static. It's boring. You wouldn't use Roact for this. That'd be a waste. So let's talk about your dynamic UI. make our alias again. It's an alias we're testing. We haven't used it in any production code yet, but it's kind of mirroring a project called Hyperscript. Their alias they use is H. It's kind of odd. So we'll make a component this time. A component is just a function in the simplest case. It accepts a table called props that just has some values on it. So here we're passing in the current time. And then again, we just return a description of what we wish the UI looked like at this point. We say, oh, I wish there was a screen GUI. It had a text label named time. And yeah, it tells us what the current time is. Then we'll create our UI. We're just going to use tick for time. There aren't any really good date formatting libraries available right now. I mean, I did have an example of one, but we haven't released it yet. So we'll just use tick. And we'll tell Roact again, here's a description of my UI. We're making an instance of our clock component. And we're giving it our current time. Put it in the player GUI. So now the time is here. It's static, though. We want to update it. So here's my super lazy loop. And we're going to loop over forever. Every 300 milliseconds, we're going to check what the current time is, a tick again, and we're going to update the UI. This is the simplest case of how to update your UI in Roact. You'd use this if you were embedding Roact in an existing project, for example. One more example. Alias again. We'll define another component. This time it'll be in piecewise. This time we're going to talk about an inventory. We're just going to use a list for our inventory because there's intricacies about laying out grids that I don't want to talk about. So we pull something out of props. It's just a table that has items in it. And we'll start describing what the children of our inventory component will be. We're going to use UI list layout, laying it out with enums, sort orders, layout order, kind of a tongue twister. And then we'll just write a regular old loop. In a lot of templating systems, especially in JavaScript, they have to create special syntaxes for rendering lists of things. The real advantage of the React model is you can write regular Lua code to generate your interfaces. And this will run anytime there's a data update. So here we'll say for every item, I wish there was a text label that was laid out here, and it had the right text, and it was sized correctly. And then finally, we'll just say, oh, yeah, and all these things are bundled together in a frame, and it has some fixed size and has some children. Then to actually use it, we describe our data just with plain old objects, like we have a katana of doom, but you also have a health potion in your inventory. Then we'll describe our UI with that set of items and make it real. And then at any time, we can mutate. In this case, we're mutating our table of items. We could also immutably create a new set of items if we wanted to, but there's no built-in features in Lua to do that. Then we describe a new UI, and we say, hey, Roact, update the existing UI to match this. And Roact will do its best, to the best of its ability, will update that in the most efficient way possible. Again, the goal, when we step back to the component, right, we didn't describe any state changes. We didn't describe what happens when we resort items or what happens when anything happens. You can just change the order of the items, and the order of your UI will magically update. These libraries are all available today on our Roblox GitHub. We have a whole shebang when it comes to open source development here. We have full licenses. We have contributor guides. We're accepting pull requests, new features. It's a full effort to try to bring this forward. So if you click through these things, you can actually see we have our GitHub. This is also, let's see, let me step back. Right, so yeah, so we have everything available on GitHub. You can see everything's laid out in files. It's not just RBXLX files. It's actually source files that we build together with another tool. We have full API documentation with pretty colors and warnings and things like that. So you can check these out as well. We have a getting started guide that will walk you through how to get started with Roact and what the real benefits are, besides just what I've talked about in this presentation. Finally, I've put together a more complicated and comprehensive example under my GitHub account that's also available for the slideshow. It talks about using Rodux as a replicated store, which is an idea that Voxel proposed to us. It also talks about using strongly typed remote events to communicate with Roact, as well as doing some really interesting things like using Roact to represent your game world, or how do I embed Roact in my existing project that doesn't think about UI and data in these ways. Cool. You can talk to me at any time, the dev forum, LPG Hack Guy. You can also tweet me, same username pretty much everywhere. I think it's time for Q&A. Bob.
Do we provide Roact or Rodux as module scripts on the website?
We don't right now. We do publish RBXMX files off of the GitHub in the releases there. We should publish them from the official Roblox account as well. But the recommended way is to retrieve them from GitHub. When we have a real package system, we'll also publish them there.
link to the GitHub again?
Oh,
Link.
yeah. All these links here. So github.com/Roblox. It has all of our open source, including our core scripts as well.
So earlier, someone was mentioning that Roblox is going to be introducing some sort of package management system or something like that. Is Roact going to be in there as soon as that comes out?
Yeah, for
Sounds
sure.
good.
This is one of the motivating reasons for a package manager is actually trying to promote like more open source development.
Would you say that Roact and Rodux is it in a beta stage, or would you say it's ready for production?
It's ready for production. So we're using it. We're launching new pages that are written in Lua in the mobile app, and we also have a significant portion of Xbox now rewritten in Roact and Rodux. So I'd say it's ready. There are not going to be any more breaking changes for the Roact API or the Roact Rodux binding APIs. There are some ergonomic changes we want to make to Rodux that are very minor and very cosmetic.
Would it be possible to get some tutorials on the Roblox wiki about Roact and Rodux? Just
Definitely.
Make it easier for everyone.
Yes.
Thank you.
So the stuff that we're getting from GitHub, are those scripts showing us how to use these, or do we have to embed those scripts into our system? I guess I can ask, is Roact and Roact, are they actually API items, or do I have to include these module scripts myself?
You'll have to import them into your game.
I have to port them in the game.
So the easiest way to do that is just drag and drop the model files straight from GitHub into your game. Yeah.
I was interested in Roact, but what seems to be one of the big problems with it is that you, as far as I know, you have to make your UIs with Roact, and that means with Lua, which means that it's less visual, I guess I could say. With the current Roblox GUI model, it's really easy. You open Studio, you mess around with GUIs, and then once you're actually good with it, then you can start doing the scripting. But with Roact, the problem seems to be that you have to make your UIs entirely in Lua, and you have to constantly play test, and it seems really frustrating. Is there anything that could be done in that area?
Yes, so there's 3 projects specifically we've been working on. So the first one, the demo that I actually have in my RDC project, is a hot reloading example. So you can actually run start server, start player, and it'll reload your entire game, every code change, transparently without respawning players or losing any of your state. So then you can actually you can actually put your text editor on the left side of your screen and Studio on the right, and as you edit, you'll see your UI update. After that, we also have a prototype of React hot loading, or our version of React hot loading, that can dynamically switch in components as you edit.
Great,
Thank you. That's all on the backbone of a project I have called Roho for syncing code into Studio in real time.
Thank you.
All right. Thank you.